Are again. Today we're going to be doing lesson 14, and it's taking out the GCF, which is the greatest common factor, and also factoring by grouping. Now, in the last unit, we learned about how to multiply two binomials together. In this chapter, we're supposed to do the opposite. So, in 7th grade, you learned earlier this year, when you distribute, you take the number sitting on the outside and you multiply it by each term on the inside. Well, now we're going to go backwards. And anytime that we are going to be factoring, we always have to look for the greatest common factor. That's the number one thing that we have to do every single time. So if I'm looking at this right here, what I'm going to look at is I'm going to look at each term separately and say, what number goes into each one of these? So what number goes into 12, 15, and 27? In this case, 3 goes into each one of these. If I take out a 3, that means I'm left over with 4x squared. So what did I really do? Instead of multiplying, I divided. So on this one, I'm going to get a 5x. And then last but not least, I would get a 9. Now, some of you are probably saying, well, why didn't you look at the variables? Well, if you notice, on 27, there are no variables. And so we didn't look at the variables on this one. But if I was to multiply this 3 back through, if I was to multiply it back through on each one of these by distributing, would I get what's over here? I would. And so that means that I have taken out my greatest common factor and I did it correctly. And again, when we come down here to do these problems, you will again notice it says if the to take the GCF out, but this is the other thing. If the first term is negative, then we need to take out a negative along with our GCF. So let's do some of these problems. We're going to come down here and look at this one first. So looking at 12, 3, and 6, what do they have in common? If you notice, they all have a 3 in common. Great. But this time, they each one have an M in common. What's the lowest amount of M's that they have? Here we have a 2, here we have a 6, and this is an invisible 1. So what is the lowest number of those three? What's the lowest exponent? And it's 1. So we're only going to take out one of those. Then we look at the exponents of the n's. And what is the lowest of the exponents of the n's? It's 3. Now remember, since we're dividing and we're dealing with exponents, we're going to subtract those exponents. But we will divide the coefficients. So 12 divided by 3 would get us 4. M squared divided by m, so I'm subtracting 2 minus 1, will get us 1. So I have 1 m there. Then I have an n. Well, I had 5. There are 3 here. So I take away 5 minus 3, and I have 2 left over. Now here I have 3 divided by 3. 3 divided by 3 is 1. We don't need to write the 1. Now if you want a little invisible 1, you're more than welcome to put it. But I'm taking out 1 m, so 1 left over. Or I said taking out 1, I have 5 left over. And if I take out 3, I again have 5 n's left over. Then I look at my 6. 6 divided by 3 is 2. M to the first divided by m to the first, that's just 1. So we don't need to write down an m at all because they've canceled each other out. Then I have an n to the third, I have an n to the third. So n to the third over n to the third is 1. So I'm left with this right here. Now if I was to multiply that through, would I get the original equation? I would. So let's try it another time. And I'm going to go down. I'm going to go straight down. Now, some of you may have printed out, or some of you may be just copying this as we go. Either way is perfectly fine. So first things first, what's in common? If you look at the coefficients, we have a 2 in common because 2 goes into 4, 2, and 6. Then, do they all have an m? They do have an m. Now, what's really fun about this one is how many m's do each one of them have? They have an m squared on each one of them. Now, do they have an n in common? They do have an n in common. How many n's do they have? Well, they have 3, 2, and 1. What's the lowest number of n's? 1. So then, inside, I divide my 4 by 2, and I get 2. The m squared is going to cancel out. Now I have 3 n's, n to the third over n, so that means I'm going to have n squared left. Plus 2 divided by 2, it's that invisible 1. If you want to write it, that's fine. Then I'm again taking out the m squared, so those canceled out. I had 2 n's. I'm taking out one of those n's, so I have 1 n left over. And last but not least, I look at my 6. 6 divided by 2, 3. M squared divided by m squared, 1, so we don't need to write that. And then n divided by n, 1. So here we have our answer. Now, the next ones, they're binomials. So sometimes they're a little easier to look at. So let's look at these. You may be looking at it and saying, man, they have no numbers in common. They have no variables in common. But look again. Didn't it say up here that if the first term is negative, your GCF needs to be negative? So what number do they have in common? They only have 1 in common, but I need to take out the negative. So I'm going to take out a negative 1. And when I do that, I'm left over with 3x minus 5. Because if I was to multiply the negative 1 through, I would then get the negative 3x plus 5. Okay, so let's do this one. Ooh, this is big. Now they both have a 2 in common. Do they have the 3 in common? I think they do. 2 times 3 is 6. I bet they have a 6 in common. What do you think? Do they have a 6 in common? I think so. So I'm going to take out a 6. Do they have x's in common? They have 1 x in common. Do they have a y in common? Yep, they have 1 y in common. So I do this. 18 divided by 6 is 3. X squared divided by x is x. Y divided by y is 1, so that goes away. Minus 42 divided by 6 is 7. X divided by x goes away. Y to the 5th divided by y gives me y to the 4th. Now let's look at this. One more. We're going to go ahead and do a couple of more on this. Let's go up to number 3. Let's look at it again. Thought we would do a couple of easier ones in the middle here. But now we can go back up to the one, and it's not even hard. It's just it has lots of stuff to it. And you guys get freaked out sometimes about the stuff. So what number do they have in common? They have, let's see, a 2 in common, because 2 goes into 14, 4, and 10. They each have a p in common. The smallest amount of p's is 1. Then they have a q in common. How many q's? Q squared is how much they have in common. And then there's an r. They only have 1 r, so then I do 14. That would be 7. P to the 9th. Then the R goes away. Oh, I just messed that up, didn't I? No, I didn't. Sorry. Then I have the Q squareds go away. The R's go away. So then I'm on to my next one. 4 divided by 2 is 2. P to the 6th divided by P is P to the 5th. Oh, Q squareds go away. Then I have an R to the 3rd divided by R and get R squared. Last but not least, 10 divided by 2 will get us 5. P divided by P goes away. Q to the 3rd divided by Q squared is going to be Q. And R to the 7th divided by R is R to the 6th. Okay, right now I want you to go ahead and do number 5, and then 7 through 9 and 11 through 13. I want you to do that on your own. Okay, so let's go ahead and look at those answers. If we look at those answers real quick, this is what you should have gotten. And hopefully that's what you got. If you look at 13, it says not factorable. That means on that one, there's nothing that is in common with them. And so there's nothing else to do, so you just say not factorable. Okay, so next, I'm going to go back to this. We're going to go down here to this. The second part of today is factoring by grouping. And this is when you have 4 terms. In order to do factoring by grouping, you need to have 4 terms. Now, we just learned how to take out or factor out the GCF. That's the first step. The first step, in fact, oops, I used the wrong thing. The first step in factoring is always taking out the GCF. Always, it's a must. Now, there are some additional things that we can do. The first thing is look for the GCF and then factor by grouping. Okay, and if you look at this, it says separate 4 terms into 2 separate groups. I just separated it into 2 different groups. I have the first 2 terms and the last 2 terms. So I look at the first 2 terms and it says to find the GCF of each group. So I look at this. I have y squared and I have y. So what do they have in common? They both have, you know what? I'm going to actually not write it like that. I'm going to put this in here. If I take out that y, I'm left with y squared. Then on this one, what do they have in common? They have an x in common. And when I take out that x, they have a y plus 1. Now, I purposely wrote it like this because do you notice that the orange, or burnt brown or whatever color that is, these are exactly the same. And because they're exactly the same and these are multiplied together, I can factor them out. That's the GCF. The GCF of the first part is y plus 1. The GCF of the second part is y plus 1. Now, I just did those, but what's left over? What else do we have in each term? We have a y and we have a plus x. Okay, now if you were to check it by multiplying, well, let's see what would happen. If I multiplied this, I would get y squared. If I multiplied this, I would get xy. If I multiplied here, I would get y. And if I multiplied here, I'd get x. Now they're in a different order, but I got the correct answer. So this right here is my answer. Okay, so let's try that again. I know it was a little rough, but let's try it again. So I'm going to cut this in half. Not really cutting it, just splitting it up. So I look at the first two. What do they have in common? They have a y squared in common. What's left? There's a y minus 9. Plus, what do these two have in common? Oh, you're going to say nothing. Well, they actually have a 1 in common. Now, if I look at this, I'm actually going to highlight it for you. This right here and this right here. Oops. Let's undo that a little bit. Oh, I didn't want to get that 1. Those are in common. So, what's in common on both of those is y minus 9. So if I was to divide both of those in those terms, I would end up with y squared plus 1. So sometimes I've told my kids, whatever they have in common, write out front in set of parentheses. And the second set of parentheses, what's left over, the part that I didn't highlight, goes in the other set of parentheses. Okay, so let's do another one. Okay, let's look at this one. Oh, we'll just change up the color a little bit. Okay, I look at the first two. And I get x squared. Okay, so that's x plus 12. Awesome. Then I look at this other one. Now, didn't we say that if the first term was negative, to factor out a negative? So they also have a 5 in common. So I'm going to take out a negative 5. So negative 5x divided by negative 5 is just going to be x. Negative 60 divided by negative 5 is going to be a plus 12. Oh, look. Right here and right here, each of those parentheses are exactly the same. So since they're exactly the same, I'm going to write them down. There's only one of them because we're factoring it out. Then the other set of parentheses are the leftovers. So the x squared minus 5. And voila, we have the answer. Okay, let's try it one more time before I let you do it on your own. Okay, so here we go. Let's change the color again because I want to. Cut it in half. What do the first two have in common? They have an x. X plus 8. What do these two have in common? There's a leading coefficient of negative 1. So I've got to have a negative that I take out. What else do they have in common? They have a y. So x plus 8. Look at that. I have an x plus 8 and an x plus 8. That's amazing. So I write that down. X plus 8. Then what's in my leftover? X minus y. Okay. So I want you to do these next two problems on your own. Okay. And here are the answers. Okay. Now, if you notice on 26, 20, oh, there are two 26s. Interesting. This one that's supposed to be the 27 right here, 26, 27, and 28, you had to take out the GCF first. So let me go back to that and show you that. I should have done that with you, I guess. So if I look at number 26, starting off, don't they have a GCF already? Doesn't 2 go into all of these? So I would have a 2 out front. Then I would have a 2x to the third minus x squared plus 8x minus 4. And then from there, I need to do the steps that I was already doing. Now, sometimes I actually make it into a bracket instead of just parentheses. I look at the first two. They have an x squared in common. And if I take out the x squared, I get 2x minus 1. Then I look over here. I have a 4 in common. And I get 2x minus 1. Then, oops, I didn't mean to that. I meant to do that. Those are in common. Now, you have to remember that that 2 is still out there, so that 2 stays there. I write the 2 sets of parentheses that is in common. I write that there. And then the leftovers, the x squared plus 4, I put there. So if I was to multiply that totally out, that's what I would get. So let's go ahead and look at number 28. That's right here also. So if I look at 28, ooh, it has a leading coefficient that's negative. So I should take that out first. But do they also have anything else in common? I don't think so. I only think that they have a negative in common. So then I would get 12m to the third negative 20m squared minus 9m plus 15. And so then I would do the exact same thing that I was doing before. And I split it. I make this 4m squared. And then I would have 3m minus 5. And then these two over on this side have a negative in front of it again. So I take out a negative 3. And I would get 3m minus 5. Look at that. I have it again. So my dogs are going to bark, so I apologize right now. So they have that in common. So I have a negative 1. I have a 3m minus 5. And my leftovers. So I hope that helped you. And again, I will show you the filled in totally of these notes so that you can see. Actually, I'm just going to do those for a second so you can see that. And if you want to pause the video, you can. And then the ones up above, again, I will show those. Okay. Let us